for today is criticality in a nuclear reactor. So, in a nuclear reactor, what is criticality? What concept is called as criticality? We must have to understand that. Moreover, we must have to know the significance of achieving criticality. Okay, so let us understand all these things in this news article. So, recently, the fourth unit of Kakrapar atomic power station, which is located in Gujarat, has achieved its first criticality. So what is criticality here? It is the beginning of the regulated fission reaction. So what is criticality? Beginning of the regulated fission reaction is called as criticality. So we must have to understand what fission reaction is here. Okay. Next, it paves way for its eventual transition to generating power for commercial use. Obviously, when criticality is achieved, generating power for commercial use is made possible. Okay, and then criticality, we already know that it is the first step towards power production, and a nuclear reactor is said to be critical when the nuclear fuel inside the reactor sustains a fission chain reaction. So this fission reaction must be a chain reaction, then only it is said that it has achieved criticality. Okay. Moreover, each fission reaction releases a sufficient number of neutrons. This is also there. Okay, we are going to understand this in a short while. Okay, so each fission reaction releases a sufficient number of neutrons to sustain a series of reactions. Okay, and then heat is produced in the event, and this heat is used to generate steam, which then spins turbine to create electricity. So this is how nuclear reactors are used for production of electricity. So this fission reaction is there. This fission reaction will lead to production of neutrons, and this neutrons will sustain that chain reaction. Okay, and during the chain reaction, heat is produced as a byproduct, and this heat is being used for creation of electricity. Okay, it will be used to generate steam, which will then spin turbine and electricity is produced. Okay. So fission reaction. So what is a fission process? Fission is a process in which nucleus of an atom splits into two or more smaller nuclei. We already know these are basic school concepts, fission and fusion. Okay, so what is fission here? An atom. Okay, so here the nucleus of an atom splits into two or more smaller nuclei. Nucleus of an atom is there, and then it is splitting into two or more smaller nuclei, and byproducts are also released. Here byproducts should be heat. Heat here is the byproduct. Moreover, neutrons are produced, and those neutrons will sustain the reaction. So that is why it is called as chain reaction. It goes as a chain reaction, and even this nuclei will split into two and also release 3 neutrons, which will again sustain the reaction. That is why it is called as sustained chain reaction. And when the nucleus splits, the kinetic energy of the fission fragments is transferred to other atoms in the fuel as heat energy, and this heat energy is what is utilized for production of electricity, which we already discussed. Okay. What else do we have to understand? What is the significance of achieving criticality? That we need to know. First is, it is the milestone for power generation, which we already know that this stage demonstrates that the reactor can produce a controlled and continuous chain reaction essential for sustained power generation, and it is a precursor to a full operation and power generation for commercial use. Okay, and then these nuclear reactors or nuclear energy also paves way for energy sustainability. Okay, and it also paves way for achieving climate goals. Let us understand that. So nuclear energy as a low carbon source, it is a low carbon source and it is a renewable energy. Okay, so nuclear energy being a low carbon source aligns with India's climate goals to increase its renewable energy share. We have a climate goal. What was that? What is that? India aims to generate 50% of its electricity from non-fossil fuel source. At present, we are heavily dependent on fossil fuel sources for electricity. But then we have this target aim to generate 50% of its electricity from non-fossil fuel source by the year 2030, and this target was fixed during the COP, Conference of Parties meeting 26 in UNFCCC, okay, which happened in Glasgow in the year 2001. Okay, this happened in the year 2001. Now let us understand about the reactors which is present in this Kakrapar power station, and then how is it different from the other reactors in the power station. Okay, Kakrapar reactors. So the existing Kakrapar reactors, that is unit 1 and unit 2 reactors, have a capacity of 220 megawatt each, but then the new ones has a capacity of 700 megawatt, that is unit 3 and 4, and they are among the safest reactors in the world. Why are they the safest reactors in the world? That is because this unit 3 and unit 4 reactors have steel lined inner containment system. Okay, so they are very safe. They are having this steel lined inner containment system that prevents any radioactive material from escaping in case of a nuclear accident. Okay, so in case a nuclear accident is going to happen, then this steel contained system will be preventing any release of radioactive material, which is very important. Okay, and they also have a passive decay heat removal system. So what is this passive decay heat removal system? That is, when the nuclear reactor is shut down, it will automatically cool down the reactor. That system is called as passive decay heat removal system. That is also integrated with these two reactors, that is unit 3 and unit 4 reactors of Kakrapar power station. So this is what we need to understand about achieving criticality, what is its significance, and about the reactors in Kakrapar power station.